In this problem, this point, suppose this is P. As it lies on the line x plus y equal to 4, I assume the coordinates as t comma 4 minus t. Now, this is the chord of contact. These are PA and PB, the tangents. This is the chord of contact. What I want is locus of the midpoint. If I call the midpoint as x1 comma y1, I want its locus. Now to find that, I'm going to write equation to this line in two ways. One is it has this as midpoint, so its equation is s1 equal to s11. So writing s1 equal to s11 for this, I'll have the equation as xx1 plus yy1 is equal to x1 square plus y1 square. And also this is chord of contact of the point P. Therefore, its equation is s1 equal to 0 with respect to this. So writing s1 equal to 0 of this point with respect to this circle, I'll have tx plus y into 4 minus t is equal to 8. Now these two equations represent the same line, so the corresponding coefficients are in proportion. So I'll get x1 by t is equal to y1 by 4 minus t is equal to x1 square plus y1 square by 8. Now all that you need to do is to eliminate t from the equations. Using ratio and proportion, here I can write one more ratio, that is by in the denominator I'll have 4. Now you simply take these two, you have the locus. Okay, let's go to next problem. Now in this problem, for the function to be defined, first of all, this part has to be greater than or equal to 0. Cos inverse of root log x to the base 4 minus pi by 2 greater than or equal to 0. Means this should be greater than or equal to pi by 2. But we know that cos inverse, as this cannot be negative, cos inverse maximum value cannot be more than pi by 2, and it takes pi by 2 only when this is 0. That means x must be is equal to 1, then only this will be 0, the whole thing will be 0 and all that. So the only value for which this entire thing is defined is for x is equal to 1, and obviously for x is equal to 1 this part is also defined. Therefore the domain of the function is nothing but set having only one element, namely 1. Now you simply go for f of 1. The first part obviously is 0 plus sine inverse of, it's 2 by 4, I'll get 1 by 2, so that is 30 degrees means pi by 6. Therefore range is nothing but just singleton pi by 6. Let's go to next problem. So as I have the information about f of x square, in this I go for f of x square in this one. So from that I have f of x square is equal to integral 0 to x square t f of t dt. He gave f of x square as x power 4 plus x power 5. Now I take this and this, simply differentiate both the sides. I'll have 4x cube plus 5x power 4 is equal to, it is x square into f of x square into 2x. So cancelling x cube on both the sides, we have f of 2 times f of x square is equal to 5x plus 4. Now rest is obvious. You see, I want f of r square in terms of r's. If I write, I have f of r square will be 5 by 2r plus 2. So sigma f of r square r equal to 1 to 12 is nothing but 5 by 2 times sigma r equal to 1 to 12 plus 12 to 24 I get. Now rest is obvious. You simply write the value there, 5 by 2 into n into n plus 1, but that is sum to first and natural numbers plus 24. So that will be 195 plus 24, you will have it as 219. Let's go to next problem. Before we start the problem, let us study the behavior of this curve. Let us see the intervals of monotonicity. If I go for the derivative, you can see that I have the derivative as x square plus 1 whole square, x square plus 1 minus 2x into x plus 1. I'll have it as minus of x square plus 2x minus 1 by x square plus 1 whole square. Now let us study the sign and also see where the derivative is equal to 0. As the denominator is positive, I don't have to worry about the denominator. Let us just focus on the numerator. Now for the numerator, if I simply complete the square there, I'll have x plus 1 whole square minus 2 I'll get. So the factorization, it yields minus of, it is x plus 1 plus root 2 into x plus 1 minus root 2 by the denominator x square plus 1 whole square. So obviously we can see that it is positive between the roots and negative beyond the roots, because the leading coefficient has sign negative. Between the roots it's positive. So the roots are nothing but minus root 2 minus 1 and root 2 minus 1 are the roots. So you can see that between these points the derivative is positive, means the function is increasing, and beyond the points the function is increasing. That means the graph will be like that, and beyond these 2 points it is going on decreasing only. So I'll have going on decreasing. The graph will be like this. This is the graph of this one. This is how the graph looks like. So let me see the points where y equal to 1 is intersect in the curve. So solving them, I have 1 is equal to x plus 1 by x square plus 1, or I have, simplifying, I have x square is equal to x, that means I have x equal to 0 or 1 I am getting. So those are the points, common points. You see, this is a rough notation only. Why don't exact position of x-axis? This is a rough presentation. Now you can see that 0 and 1, 0 lies this side, and suppose this is 0 and somewhere here I have 1 here. Okay, now at 0 what is its value? At 0 it is 1, and at 1 what is the value? At 1 also it is 1 only. Therefore at 0 it is 1, at 1 it is 1. Now that is the line y is equal to 1. So you can see that throughout the common points it is lying between 0 and 1. Now therefore the required area is nothing but integral 0 to 1 upper curve minus lower curve, that is x plus 1 by x square plus 1 minus 1 dx. Evaluate the integral, you have your required area. Let's go to next problem.